had stopped talking about the probability of events and all that. So we're now going to talk about the probability of some event called A. Some event called A. All right? So now, this event called A, what does it consist of? Elementary events. Yes. So there is in A is some S1, S2, up to S whatever, from where S sub I is an element of the sample space. Right? So, the example we looked at was, what if A was at least one head with the 2 coins? What was the sample space? So, the two coin flips, right? What was the sample space?
Heads and tails.
Sure. So in this example, it was tails, 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 heads, heads, tails, and heads, heads. Those are the individual, okay, or basic or primitive events. All right? So if the event A that we're considering is there's at least one head, what would A look like? It would be tails, heads, heads, tails, and heads, heads. Right? So notice that A, okay, which is some set of these primitive events. That's not the term they use. What word do they use? Elementary events. Yeah. So A is some set of elementary events that come from S. All right? Here's the example. Here's the sample space. Here are the elementary events that come from S. So the probability of A is what? It's the summation for all the little S's in A of the probability of that S. Does that make sense? Let's try it in this example. If it's a fair coin, what's the probability of each of these events?
1 over 4?
It's a fourth, right? Because it's uniformly distributed. So the probability is 1 in 4, 1 in 4, 1 in 4, 1 in 4. So what's the probability of A? It's 1/4 plus 1/4 plus 1/4. So what's the probability of at least a head?
3/4.
3/4. You got a 75% chance of getting at least one head. All right? And that's the formalization of that idea. Okay? Now, you have to be careful. Why can we do this? What do we know about the elementary events relative to one another? They are